Okay, determining if a reaction is a redox reaction or not. There are two methods that you can use to do this. I'm going to talk about the second method first, and then we're going to talk about the first method. I label them method 1 and method 2 based on my lecture notes from chapter 10. So you're going to follow the same 3 steps. The thing that changes is whether or not you're doing method 1 or method 2. You can choose to do one or either. You can do a combination of the two, whatever you're comfortable with at any given point in time that you're working on a potential redox reaction problem. The type of redox reaction questions I will ask you will be similar to what you saw on the quiz. This question is taken directly from quiz 8. I will not be asking you about batteries, cathodes, anodes, any of that, because we didn't cover that in lecture. On chapter 10 lecture notes, I showed you which sections we actually covered, and the homework I gave you was only pulled from the sections that were covered. So method 2. The first step is always determining the oxidation number for each element on both sides of the reaction. If you're using method 2 to do this, you're using the shortcuts. And these shortcuts are as follows. I look at the element. I have iron solid. Based on the shortcuts, I know that elements in their pure form have an oxidation state of 0. I ignore the coefficients. I also ignore the subscripts when I'm using method 2. Oxygen gas, that's an element. It's an oxygen bonded to an oxygen. That also has an oxidation number of 0. Now I come over here to the product side. I have iron oxide. I know oxygen in any compound form is going to be 2 minus 2. Now this is where the subscripts come into play. If you have a compound, you need to make sure that the overall charge, so iron oxide has no charge up here, no overall charge, it's neutral. So I need to make sure that all of my charges from all of these oxygens plus all of the charges from both of these irons, when I add them all together, I get a total of 0. So iron, there's no hard and fast rule for what cations are like in a compound. I know that oxygen's always minus 2, so I can do math to figure out what the iron is. I know that overall, all of my oxidation states have to equal 0. I know oxygen is a minus 2, and I have 3 oxygen from this subscript. That should equal the oxidation number of iron, which is some number I don't know. And I know I have 2 from the subscript. Again, the balanced coefficient don't matter. So this big 2, this 3, and this 4 do not count when you're doing oxidation state and redox reaction problems. So this comes from the subscript here. If I solve, this is a minus, this becomes minus 6 equals 0. You know that 2x now equals 6. If I add that to both sides, if I divide by 3, that tells me that my oxidation state for iron is plus 3. Now I have all the oxidation numbers. I'm done with part 1. Part 2, I have to compare them. So for iron and oxygen, these are the only two compounds in this reaction, reactant side, product side, and I'm going to list out the change that happens. Iron started as 0, oxygen also started as 0, and in the end, in the products, iron became +3, and oxygen's oxidation number was -2. The change from reactant to product for iron, it went from neutral to positive. That means it lost electrons. Lost electrons is oxidation. From oxygen, it went from neutral to -2. That means it gained electrons. That's a reduction. This is step 2. This is step 1. Step 3. So did 2 things change? Yes. Iron and oxygen both changed their oxidation state numbers. Was one of them a Leo? Yep, the iron was oxidized and the oxygen was reduced. So I have a redox reaction. The second way you could figure out this problem, it's going to look pretty similar. Method 1, I'm going to go through method 1 now. It's going to explain where the shortcuts come from. So iron solid, if I'm trying to figure out the oxidation number and I have forgotten all of the shortcuts. Iron solid is a metallic network. All of the ions are attached to each other through metallic bonds. And metallic bonds are like covalent bonds. And so because they're all attached to each other, the way that we determine oxidation number is we do the oxidation number bookkeeping. And the bookkeeping rules are as follows. The atom that is more electronegative gets all of the electrons when you're doing the bookkeeping. It doesn't literally get all of the electrons, but for bookkeeping and accounting purposes, we say that it gets all the electrons. Well, iron solid, iron and iron have the same electronegativity. They're the same element. So they're all going to just share electrons equally. So the oxidation state for a metal solid is 0. Same for an elemental compound. Oxygen bonded to oxygen. There's no atom that's more electronegative than the other, so the oxidation number is 0. Again, coefficients don't count. Now we come to the product. I have oxygen bonded to iron. This goes way back to chapter 5 and chapter, I think, 4 or 3, where we were predicting compounds. I know that this iron has a +3 charge. This oxygen has a 2- charge just from its state, and I know that it takes 3 oxygens to balance out 2 irons to get a neutral overall compound. But again, these subscripts don't really matter unless I'm checking to make sure that the overall oxidation numbers make the overall charge accurate. So here I can just look at each element. So now I have these separated into their respective ions, and I can see that this iron, it's not bonded to anything else. It's an ion, so it says ionic bond. But now this iron, instead of being neutral solid, it has a charge. 3-. That's telling me oxidation state, that should be a plus. Oxidation state is going to be +3. And the oxidation state is going to be -2 for oxygen. You will find for any compound, when you have an oxygen, the oxidation state is always going to be -2. We can go through another example if you would like. Please send me an email. So in this case, I have figured out the oxidation numbers. Instead of remembering the rules, I have used my logic and what I know about how the accounting works to figure out the oxidation numbers. Step 2 is going to be the same. I then compare just like I did above. And I should get the same answer. I still see that iron in its solid form was neutral. Oxygen in its elemental form is neutral because there's nothing more electronegative between these two. And then if I have an ion, that iron ion now has plus, again that should be +3 oxidation number, and the oxygen has a -2. Iron lost electrons, so it was oxidized. Oxygen gained electrons, so it was reduced. I have a redox reaction. So now the reducing agent is always the opposite of what it's assigned as. So iron got oxidized. That means it was reducing the reducing agent for the oxygen. So the iron lost electrons. Where did those electrons go? To the oxygen. The oxygen gained electrons. Where did they come from? From the iron. The iron was the reducing agent, the agent by which the oxygen gained electrons. The oxidizing agent is the oxygen. The oxygen got reduced. It took electrons. Where did those electrons come from? They came from the iron. So the oxygen was the agent by which the iron lost its electrons. Okay, hope this helped. If you would like a couple more examples, let me know.